Okay, kiddos, today we're going to be learning another basic exponent rule. So today we're going to look at what happens when we have terms of exponents on the top and the bottom, the numerator and denominator of fractions. So here are some really basic examples. Again, we're going to start out by writing the expanded form, and then we're going to try to generalize a shortcut for how we can get from the problem to the final answer without having to do all that work in the middle. So 10 to the 6th, if you remember, that just means 10 times 10, but we're going to be doing it 6 times. So it's 10 times 10 times 10 times 10 times 10 times 10. On the bottom, we have 10 to the 4th, so that's 10 4 times. And then we can cancel things out. If you have a number on the top and the bottom, the same number, they cancel out. And we have 10 squared left over. We do the same thing with the x terms. X to the 8th means I have x multiplied by itself 8 times. 6, 7, and 8. X cubed on the bottom means I have 3 x's. And again, I can cancel things out. So I have 1, 2, 3, 4, 5 x's, x to the 5th power. Okay. Now the third one, we have 2 different variables, but we still do the same thing. I have x cubed on top and y to the 6th, so that's 6 y's. And then on the bottom, I have x squared and then y to the 5th. Okay, now looking at what is left over after we cancel terms out, I have 1 x on top and 1 y. Now looking at going from the problem to the final answer, I can see here, hopefully the same thing that you see, is that if I take the exponents and I subtract them, so keep the 10, subtract 6 by 4, I get the 2. If I keep the x, take 8 and subtract 3, get the 5. And then here, even with 2 separate variables, if I keep the x and do 3 minus 2, I get 1. And if I do 6 minus 5, I get 1. So turns out here that the rule, the shortcut that we can use is we're going to keep the base and we're going to subtract the exponents. So again, here is the rule. If you were to look at a math book, this is what you would see. You're going to keep the base and you're going to subtract the exponents from one another. Looking at the example down at the bottom, it's super easy to see. You keep the 5, you subtract 7 and 3, and you get 5 to the 4th power. Okay. Now, we have some really, really straightforward examples. We're going to look at 4 examples here of what we would do if we were to keep the base, subtract the exponents. So we're just applying that rule. So for the first one, we're going to keep the base of s. We're going to do 12 minus 4, and that gives us s to the 8th power. Next one, we're going to keep the 3 and subtract 9 minus 5, and that gives us 3 to the 4th power. The next problem, we have, again, 2 different variables. We take them one at a time, so I'm going to look at my s's first. Keep the s. 12, take away 4. And then I'm going to keep the t. And 8, take away 4. And then I just clean that all up. So I have s to the 8th power and t 8 minus 4 to the 4th power. Now on number 10, our last example, we have to be very careful because here we have 2 regular numbers. I have 36 divided by 4. Now remember that fraction bar is just another way to write a division. So 36 divided by 4 is going to give us 9. And then I do the same thing with the letters I've been doing. Okay. Keep the a, 5 minus 4. Keep b, 8 minus 5. And so my final answer is going to be 9, a to the 1st power, b cubed. That is my final answer. Okay. Now, I'm sure you're probably thinking, well, in all these examples, the bigger exponent has always been on top. So what do we do if we have something like this? Now, if we were to subtract regularly, if we were to take the 6 and subtract 10, we'd get a negative exponent. And we're trying to avoid that. So we want to avoid negative exponents. So what we're going to think about is this being like a tug of war, where there are more x's on the bottom of this fraction. So the sixes are going to get pulled down. Okay, we're going to write the answer down in the denominator because that's where more of the x's are. Okay, so the 3 is a regular number. It's going to stay where it's at. It's going to stay on top of the numerator. But in the bottom, in the denominator, we're going to keep our x's there, and we're just going to subtract there. So 10 minus 6, always subtracting from the bigger exponent. And our final answer is going to be 3 on top and x to the 4th in the denominator. Okay? And that's it. So turns out that if we want to avoid negative exponents, even if we have more exponents in the denominator, we're just going to subtract there. And the denominator would stay positive because we're always subtracting from the bigger exponent. So here are some general rules, some guidelines that we can follow for our next couple examples. So number 1 is you're always going to divide regular numbers if you can. Sometimes you can't, like if you had 5 in the numerator and 3 in the denominator, you're not going to divide those. You're just going to keep them where they're at. Okay? You're going to keep the base and subtract the exponents, always remembering that we subtract from the bigger exponent. So for each term, we're always going to decide, okay, does the term go in the top or the bottom, in the numerator or denominator? And it's always based on which exponent is bigger. Okay, so let's look at a couple examples. Here we have example 1. We have a regular 5. Again, that's just going to stay in the numerator on top. Then we go letter by letter. So p's. Okay, I have 10 p's on the bottom, so that's where the p's are going to go. 10 take away 6. Now q's, I only have q's on the top, so I'm going to keep my q to the 4th there. And then r, there are more r's on the bottom, so that's where the r's are going to go. And again, 10 minus 7. So my final answer, the numerator on the top of the fraction, 5q to the 4th. And then in the bottom, in the denominator, I have p to the 4th power and r cubed. Okay, so again, step number 1, divide regular numbers if you can. Step number 2, we're keeping the base and subtracting the exponent. You're always subtracting from the larger exponent. Where the larger exponent is, that dictates where the letter goes, either in the top or the bottom of the fraction. Okay, example 2. Again, I have 1 regular number. So at the bottom I have a 4. I'm going to keep it there. Now x's are going to go on top because there's 9 there and only 2 on the bottom. So 9 minus 2. My y's are going to go on the bottom because I have 10 there. So 10 minus 4. And then z's, I only have 1 set of z's. So z to the 5th is going to stay on top. And my final answer is going to be x to the 7th. That looks like a z. Let me erase that. X to the 7th. There we go. Z to the 5th. And then on the bottom, I have 4 y to the 6th. Okay. Same steps for the next one. Here I have 2 numbers, 9 and 8, but I cannot divide those. Again, if the numbers don't divide, then you just keep them where they're at. So I'm going to keep 9 on top, 8 on the bottom. Okay. Now, the tricky thing here is your p in the denominator on the bottom does not have an exponent. So I'm going to put a 1 there. Okay. And then I just treat them like I normally would. So p's are going to go first, or sorry, m's are going to go first. So I have 10 on top, only 2 on the bottom. So 10 minus 2. Okay. Now, p's, I have 1 on the bottom and 3 on top. So p's are going to go on top, 3 minus 1. And then q's, 6 on the bottom, 4 on top. So q's are going to go on the bottom, 6 minus 4. Okay, so my final answer, at the top, I have 9 m to the 8th power, p squared. 8 on the bottom, q squared. Okay, last example. Again, we have two numbers that don't divide, so 8 on top, 5 on the bottom. Okay, my A's are going to go on top, 7 minus 4. My B's are going to go on the bottom, 9 minus 7. And my C's are going to go on top, 7 minus 3. And so my final answer is 8 A cubed C to the 4th all over 5 B squared. And that's it. So as long as you remember those general rules, divide regular numbers if you can, always subtract from the bigger exponent, keep the base, subtract the exponents, you're going to be A-okay on these problems.